Yeah. So let's start with drag and terminal velocity. We have already seen that whenever any object is moving, whenever any object moves in any fluid, then let's say this is the if this is the direction of the velocity, let's say this object is moving with a velocity v, then there is some dragging force acting on this object, which will be opposite to the velocity of this object. Okay, that thing we have seen. Now, we should also understand that in fact this dragging force, this drag force is a very, very complicated force. This is actually very, very complicated force. But for simplicity, we can assume that drag force is directly proportional to the square of velocity. This is simple assumption to make our life simple. Okay.
Okay.
Otherwise, drag force is a very, very complicated force. So what we will what we will assume that dragging force or simply drag is directly proportional to the square of velocity of the object, and it is always opposite to the direction of motion of the object. Now,
Yeah, because if velocity increases, that means the drag force also increases as well.
yes, and it increases tremendously. It increases tremendously.
Yeah,
Okay.
yeah. And until the velocity is equal to the, I mean, the force of the velocity is equal to the force acting, the balance out. So
No,
drag.
no. There is a concept here. What
Okay.
I know you are talking about the terminal velocity, right?
Oh yeah, yeah, yeah.
Okay. See, there is a point here. There is a point here is that terminal velocity we normally use this particular term for any object which is moving down, with some under the action of gravity, which is moving down under the
Okay.
action
Yeah,
of
yeah,
gravity. See, what we will do is
yeah.
we will take any type of object, and then we will write that okay, this is the drag force, uh, because this object is moving downward with some velocity v, and this is the drag force, this is the upthrust, and this is the weight. Now, what is happening is, I think we have seen this in last class also, that when W is greater than Fd plus U, then this object will accelerate. This object will accelerate. It will come down with some acceleration. Okay.
Okay.
After some time, since weight is greater than this upward force, what will happen is, due to the acceleration of the object, velocity is continuously increasing. Now, since velocity is increasing, so dragging force is also increasing. So dragging force is increasing. That means that one instant will come when Fd plus U will balance the downward force. See, while this object is falling down, there is no change. There is no change in this force and this force. There is no change at all, because W is equal to mg, and this upthrust, it is equal to volume into density into g. That's it. There is no change in upthrust and weight while the body is coming down. It is the dragging force which is increasing in magnitude, and one time will come when it will balance these two forces will balance the weight of the object, and then it will move. It will start moving with a terminal velocity, with a constant velocity, which is called terminal velocity. But the fact
Yeah.
is, what will happen? What will happen if the object is moving in a horizontal direction? For example, there is one aeroplane. Let's say there is a plane.
Yeah.
Can you tell me what are the forces acting on it?
The drag force, the
Oh,
thrust.
okay. Just tell me, drag force is upward or downward or left or right? Which direction?
Here.
Right. This is dragging. This is drag force. And what are the forces acting on it?
Uh,
What
so
else?
this is mg.
Mg downward, right? And then
This is the thrust. First. Okay.
Okay, thrust means it is due to which force?
Um,
Thrust is due to which force?
uh, um, a forward force, like so like uh,
Okay, see, this thrust is due to its internal power. Internal power.
okay,
Actually, what it is doing? Normally, we can assume like this that there is one it's what do you call it? It's okay. Aerodynamics. This aerodynamics. I think there is a chapter,
yeah,
fluid properties, fluid mechanics, fluid dynamics. There we will see it
yeah,
in detail. So here
yeah,
only one thing to remember, that this thrust is due to the internal power of the aeroplane. This is
okay.
okay. This is provided by the internal power of the plane. Now one more force is left here. What is that force? One more
Um,
force is left.
okay, so that is upwards.
Yes, this is upthrust, right?
Upwards. Yeah.
This is upthrust. So there are four forces acting on it. Now what is happening is, now this
Mm-hmm.
thrust if thrust is obviously if thrust is greater than the drag, then this plane will accelerate forward. And if thrust is less than drag force, it will never happen. It will never happen because if thrust is less than drag force, that means this plane is moving backward. Now I think we have not seen any plane moving backward. They don't have that capacity. They don't have that
Yeah,
capacity. They cannot flow backward. Okay.
yeah,
It may happen only when their engine fails. Then only it may happen that they will move awkward. So that is a different point.
yeah.
So always in case of plane, thrust will be greater than jet velocity, or at the max it will become equal to dragging for dragging force.
Okay.
So in this case, when thrust is becomes equal to drag force, then we may say that this object is moving with a terminal velocity. Okay.
Even when it's going horizontally.
Yeah, actually, terminal velocity is not used for horizontal case.
Okay.
It is always used. I have seen that always this particular term is used in case of this downward direction, downward fall only. Um,
Yeah, yeah,
okay, so better to use a term called constant velocity or zero acceleration in case of horizontal motion. In case of horizontal motion.
constant velocity. Yeah.
Okay, we can
Okay. Okay.
simply constant
So
velocity means terminal velocity, as simple as that.
yeah, yeah,
But
yeah, yeah.
okay, but by convention, but by definition, this terminal velocity is always to be used for any downward falling object.
Okay.
Downward falling object. Okay. Now, this drag force depends on certain factors. The most important factor is it depends on area of the object and velocity, the square of velocity of the object. This is the simple assumption that we can take. And if we remove this proportionality factor also, we may get something like this, drag force. I don't think this will be asked in your exams, but
Mm-hmm.
you should remember this, that it is equal to half into rho, and there is one constant. There is one constant into v square. So half rho ab square into some constant. This this particular
Okay.
constant depends upon the fluid through which that object is moving, and rho is the density of the that medium. Rho is the density of the medium. K depends on the fluid. It depends on the nature of the fluid. A is the area of the that object, area of the object which is facing the drag.
Area of object. Okay.
Okay, and V
So
is
like
the,
the area, the surface area.
yes, it is the surface area, that cross-sectional area of the
Okay.
object. So I
Okay.
don't
So
think
V is
you,
the
yeah, you have to remember only this thing. Drag
okay.
force is directly proportional to rho A V squared. Rho A V squared.
Okay.
Rho is the density, density of the medium. A is the surface area, the cross-sectional area of the object, and V is the velocity of the object. That's it.
Okay. Okay.
Okay. So,
So we
so
could can we also write that FD equals to rho times AV squared as well.
yes, yes.
This
Same.
is basically the same as FD equals a rho AV squared, isn't it?
Yes, it is the same thing. It is the same thing.
Okay.
Okay,
Okay.
so we can use this thing. Okay, now we can draw one graph also. uh, okay, this graph is not given in your book, but this is a very good concept. Can you tell me, let's say, there is one simple question. Let's take one question. There is there is one object, there is one spherical object which is falling down under the action of gravity, and
Yeah.
there is a drag force acting on it, and there is upthrust acting on it, and W is the weight of the object. Let's say this object started from initial speed 0. This object
Okay.
has started from initial speed 0. Can you draw this particular graph? How it will look like? Velocity versus time. Velocity versus time. Can you tell me this one? Just try
Okay.
once.
So so if velocity is increasing, okay. Um, um yeah, sorry, this I'll do it again. So if velocity is increasing, that means that thrust is increasing, and that means that drag force increasing. So there's a time when velocity is constant, I think, and after that it must come down.
No, no. Why it will come down? Tell me.
Because
No,
oh no,
no.
yeah,
Your answer will be only up to this much. That is the
okay,
perfect one. And this particular line will not be that much straight. It will be curved line. It will be a curved line like this. It will be a
okay,
curved line. And after
okay,
some time, it will attain terminal velocity, and it will fall down with this particular velocity only.
okay,
Okay.
okay,
So this is the terminal velocity. This is the
okay,
terminal velocity. Got it now? See, what is happening is initially this drag force is 0. Initially, this drag force is 0. Okay.
yeah,
Now, this W is greater than U. So what is happening is, in the starting when U is equal to 0, and after some time velocity is increasing, so V is equal to U plus AT. But here A is not constant. Why? Because here W is increasing, so A is not constant.
um,
Had it been constant, your graph would look like this, but it is not constant
yeah,
because acceleration is increasing. And when dragging starts, then further our this particular acceleration becomes what do you call non-uniform acceleration. This object is
yeah,
moving with non-uniform acceleration because here acceleration is increasing. Acceleration is increasing, right?
yeah,
So
yeah,
U is equal to 0, and as the time passes, drag forces is increasing. See, what is happening is, as time passes, there are few things happening simultaneously. First of all, this drag force, it is increasing. Okay, this
yeah,
increase, it goes on increasing, and 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 in the same in that meanwhile, what is happening is w w w is same. See, w is constant. There is no change in it. U is constant. There is no change in it. But
Okay.
what is changing is acceleration is equal to w minus u plus fd upon m. So this particular thing is changing. That means acceleration is increasing up to a certain time. After that, acceleration becomes zero. When
Okay.
acceleration becomes zero, when w is equal to u plus fd, then acceleration becomes zero. That means that particular after that time, this object is moving with constant velocity, which is called terminal velocity. So this is the graph of any object which is falling down with some
Mhm.
in some media which is providing dragging force with some which is providing a drag. Okay.
Okay. So when W equals zero, does that mean that then the acceleration is constant?
Uh, no, acceleration is see. In this case, acceleration is equal to zero, not constant. Acceleration is
Okay.
zero.
Okay. Yeah.
Acceleration constant
Yeah.
means it we cannot draw VT graph like this. In case of acceleration non-zero, we have to draw like this. We know that velocity time graph goes like this. This is V, this is T. Then for constant velocity, we will write like this. For non-uniform velocity, that means if acceleration is positive and constant, then we will draw graph like this. And
Yeah.
also, we will draw graph like this when acceleration is negative but
Yeah.
constant.
Yeah. Yeah. So
And
when
in
that's when it's right.
yes, and when acceleration is positive and increasing, then we will draw graph like this. And when
Yeah.
acceleration is negative, when acceleration is positive, but it is decreasing with time, it is decreasing with time, then we will draw these graphs. So there are
Yeah.
4 to 5 graphs that you must know.
Okay.
Got it? Are you aware of all these graphs?
Yeah. Yeah. So like velocity, time graphs. Yes. So yeah, and distance time graphs and stuff like that. Yeah.
Okay, so in that same thing here, what is happening is acceleration is positive, but it is decreasing. Acceleration is positive. Say acceleration is positive here.
Yeah.
During this particular time interval, acceleration is positive, but it is
Hmm.
decreasing with time. And one instant will come when acceleration will become zero. That means this object starts moving with constant velocity.
Yeah.
You got it, huh? Got it?
Yeah. Yeah. Yeah.
Okay.
Yeah. So in this equation, m is mass.
M is mass. Yes. Here
Okay.
M is
Okay.
mass. Okay. So here what is happening is this particular numerator, it is decreasing. Its value is decreasing.
Okay.
Its value is decreasing because Fd is increasing. Fd
Yeah.
is increasing. So W
Oh.
minus U plus Fd is decreasing entire term because M will
Yeah.
remain constant.
Yeah.
M will remain constant. So W minus U plus Fd, it is decreasing. And one
Yeah.
moment will come when this will become zero. And that
Okay.
particular moment, this object will start moving with zero acceleration.
Oh. Okay. Yeah. Okay.
Got it?
Now I understand it. Yeah.
Okay. Now one more question based on this. If we have thrown one object from a very large height, a very large height, we have thrown one
Yeah.
object with speed u, which is greater than terminal velocity, which is greater than
Okay.
its terminal velocity. Now
Okay.
everywhere there is one fluid, so it will experience drag. So can you tell me what will be the graph of velocity versus time here in this case?
Okay. So when u In the other case, the u was less than the terminal velocity.
It is u greater than it, we have thrown one object vertically downward with some initial velocity greater than terminal velocity. You have to
Okay.
draw the
So
graph now.
okay. So uh, okay. So the initial velocity is greater. So it starts like that. Uh, no.
Tell me what is happening.
Um, One second. I'm just trying to draw. Um, so when the initial velocity is greater, does that mean it starts from a higher number?
Yes, yes, right, right. You have to first draw like this, that
Okay.
this is the terminal velocity that it will ultimately attain.
Okay.
So
Okay.
you are correct in thinking that it will start with some higher velocity, let's say
Yeah.
u, and this is the terminal velocity. So now what is happening is it will follow this particular path. This is the graph.
Oh,
This is
okay.
the answer. Got it. So what is
Yeah. Yeah.
happening is u is decreasing, but it cannot decrease. It cannot decrease continuously. There will be
Yeah.
one point when again acceleration will be zero, because acceleration is equal to w minus f, that f plus u upon m. Now what you have done is you have thrown with some kinetic energy. Now after some time, kinetic energy is decreasing. Kinetic
Yeah.
energy is decreasing, and its kinetic energy is, see, its kinetic energy should increase, but there is one drag force also. There is one drag force also. So here, due to this drag force is increasing. So this
Okay.
particular drag force will try to oppose the motion, and one time will come when again this drag force plus up thrust will balance the W, will balance
Okay.
the W. So in this case, after some time, it will attain the terminal velocity. Is it
Okay.
fine?
Yeah. Yeah. Yeah.
Okay, so we have seen two type of graph. We have seen two type of graph. One graph is one object is just dropped from a certain height. One object is dropped from a certain height. Then we have seen that its velocity versus time graph will be like this. Okay, so ultimately it will attain the terminal velocity. Okay,
Yeah.
so this is the thing. Now we have seen one more graph where we have thrown the object vertically downward with some velocity greater than terminal velocity. So in this case, graph will go like this. Velocity versus t. It will go like this. That it will go like this. Okay, this is the
Yeah.
constant part. Now, one more question that has been asked in your book also, that let's say there is a plane, and one one person, like one parachutist, he jumps from the plane. Okay.
Yeah.
After some time, he opens the parachute. He opens the
Yeah.
parachute. You have to tell what will be the graph of the velocity versus uh, time for this particular motion.
Okay.
Tell me.
Yeah. So okay, so that this is going to be, so when it jumps, that means the initial velocity is less than the final velocity.
Right.
So so it
U.
starts off like this.
Yes. It will start from u is equal to zero.
So this is terminal velocity. Yeah.
Yes. Right. There will be two terminal velocity here. There will be two terminal
Okay. So
velocity. First terminal
Okay.
velocity will be without jumping the parachute. See, when the person has jumped, when the person has jumped,
Yeah.
so whatever you have drawn, this is this is correct up to certain point when he has not opened his parachute.
Okay.
Now, when he opened his parachute,
Oh, start. Okay.
suddenly its velocity will start decreasing,
Yes, done.
and after some time it will attain the
Yeah.
terminal velocity. So there will be two terminal velocity. One is without parachute and another is with parachute. So
Yeah.
what so whatever we have seen earlier, there are two types of graphs. That 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 combination. Now this particular example means combination of that particular graph. From from O to let's say A, we will follow one graph, and from A to let's say B, we will follow the another graph.
Yeah. Yeah.
Got it? So there will be
Yeah.
two terminal velocity. This is
Yeah.
one and this is one. Okay,
Yeah.
obviously with the okay. Can you tell me why the second terminal velocity is so less?
Um.
Why the
Yeah.
second term?
Because
Yeah. Mhm.
Yeah, because once you open the parachute has a surface area which increases the drag force, and that's why. And when you yeah, so it increases drag force. That's why this is decreasing, and at some point that terminal velocity that also reaches terminal velocity. So that's why that's why when you yeah at some point when the parachute is open, when it reaches terminal point, it goes down constant. Oh, yeah, yeah,
Okay.
uh,
Yeah, you
yeah,
are right. But here you have to say one more thing. Oh, what is happening
yeah,
is when this person was just falling down, okay, without parachute,
yeah,
when this object when this person was falling down in the sky, what is happening is here upthrust is simply the volume of the person into density of the air into g, and drag is obviously drag will depend upon the velocity, and w is his own weight. Now when he opened the parachute, what is happening is you are correct that yes, drag force will increase tremendously. Why? Because it will depend upon the area.
yeah,
Also you will increase. Why? Because now volume of the entire parachute, this particular thing will come in picture, so this
yeah,
will also increase. So both the upward forces increases tremendously, whereas
yeah,
weight remains same. So suddenly, when you open the parachute, suddenly your velocity becomes it will decrease to a large extent. Why? Because both the upward forces increases by some good amount. By some good amount, it has increased both the
okay,
upward forces. You got my
okay,
point?
yeah, 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 I understand.
Okay. So this is the case of terminal velocity and drag. Okay. Mm,
Mhm.
see, this drag velocity concept is very important. Otherwise, there are some practical applications also. A
Mhm.
raindrop. There is one question which often come in exams, that a raindrop should attain should attain attain a large velocity because it's falling from a very large height. Okay,
Yeah,
it's because it's falling from a very large height, but it doesn't do so. It falls with a very less velocity. What is the reason behind this? Reason behind is that terminal velocity itself. See, one
um,
example we can see. Normally one cloud, it will normally one that water bearing cloud or that rain bearing cloud, it is at a height of let's say 10 kilometer from the earth's
yeah,
surface, and you are just standing here, just one person is standing on the ground. Now tell me, if one object, small object, if it falls from the cloud with a rest, then tell me what is the velocity with which it strikes the head of the person.
Okay.
Neglect any drag force here. Neglect any drag force here.
Okay.
And take G as 10 meter per second square.
Okay. Okay.
Yeah, please try to do.
So we could use a Suva equation here. So the final velocity V equals U. Um, so we need to find the T value here. Um, so here we could just do. Actually, we could use V squared equation. V squared equals that. So the square root 0 plus 2 times 10 times 10. So 10 root 2, which is 14.1 meters per
14.1 meter or kilometer?
um 14.1 meters per second.
No, I think wrong. Why?
Um,
See, V square minus U square is equal to 2GS, right? So this is 0, okay. So V
yeah.
square is equal to 2 times 10 times 10 kilometer means
Oh, I didn't convert it. 1,000, yes. Okay.
10,000.
Yeah,
10,000. So V is
10,000.
equal to this thing. That means we can take 10,
450.
10. So 100 root 20. 100 root 20 kilometer meter per second. Now this is a
Yeah,
very tremendous speed.
yeah.
This is
This
such
that's
a
that's
yes.
close to 450 meters per second. Yeah,
Right. So this at this particular speed, one raindrop has a capability to just pierce our head.
yeah,
Okay. But it doesn't happen. It doesn't happen. So why? Because a raindrop attain a terminal velocity. Because a
mm,
raindrop attain terminal velocity because there is air here. Had it been a vacuum, had it been vacuum, then we are gone. Like in case of raining, we are gone. Why?
yeah,
Because okay, this is due to the air drag that we are safe. We are safe. We can enjoy the rain. So this
yeah,
particular question sometimes it has been asked, and you have to explain it. You have to explain it with some example that let's say one cloud is formed at 10 kilometer height. Then
mhm,
what will be the velocity of the raindrop had there been no air dragging force?
yeah.
But now due to air dragging
Then
force,
we,
this
yeah,
hardly it will come to 10 meter per second, or in fact this is also very big velocity, hardly 2 meter per second. It will fall with hardly 2 meter per second or 1 meter per second. Okay,
2 meters per second per, oh, 1 meters per second from
two
450.
yeah,
That's
because
oh, that's reduced a lot.
yes, this reduces a lot because if velocity is
Yeah,
more, then dragging force will become square of that much velocity.
yeah, yeah, yeah.
Okay,
It's
so if
almost equal to, yeah,
yes, so it is. This is the air dragging due to which we can enjoy the rain. Okay,
yeah,
so this is about drag and terminal velocity. Now we will see this equilibrium part. We
yeah.
will see. Okay, and
Okay,
I think after
okay.
equilibrium we have turning forces
Turning
and
forces,
center of mass. So density
mass,
and
yeah,
pressure is easy. There is no problem in it.
yeah.
Density and
Okay,
pressure are very easy. Okay, good.
yeah, yeah.
So we
They,
will require one more class. We will finish all this thing.
yeah, yeah.
Okay. Can you go to that last page 3.2 practice questions?
Practice questions, okay.
Okay.
3.2.
There question number 9.
Question number 9, okay. So a child sits on a swing.
No,
A
no, no, no,
child,
no. No.
oh, sorry, that's okay.
Last
Drag,
page
drag force
3.2.
acting, yeah. So drag force
Yes.
acting
Yes.
on a body falling through a fluid is related to the velocity of the body. By the equation, yes, K. In this case, they put K. So what does that mean? K.
K means any type of
Oh, K.
constant.
Oh, constant. Yeah, yeah, okay. Yeah. P is okay. Um, okay, so fluid is related to velocity. Okay, defined terms P and A. So, rho is no. This is what do you call that letter again? Is it rho?
Rho, RHO. This is the Latin term RHO.
Okay, but because rho is using resistivity as well in
Yes,
materials.
yes, 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 right. Rho is used in resistivity also.
Um, yeah. So I'm not sure if because in physics and generally they don't use the same terminology for two different
we
molecules.
can we can we
They
can use, see, we can use in physics, we can use one normal term like rho for various type of things. Similarly, eta we can use for many physical quantity. So you have to be very very cautious that the question that has been asked, whether it is related to electromagnetism, whether it is related to fluid mechanics, whether it is related to gravitation or mechanics, you have to be very very careful about that.
okay, yeah.
Okay, because
So
in electromagnetism rho means resistivity, whereas here rho means what? Density. Here rho means density of the fluid. Hello. ওকে ফোন করো না, আমি ক্লাস করছি একটা। Yeah, we can join after few after just 1 minute. Okay, we will join
okay,
again. Yeah, we will join
okay.
again.
So do I leave now or
Pardon?
should I leave now and join again or should I just
No, no, no. We
should I
will.
leave?
No, no. We will join again. I'm, I'm ending the meeting. You have to join again right now.
Okay, so I'll leave and then join again.
Yes, yes.